All right, students, today we are going over one of the biggest pieces of weather, and that is the pressure systems that are over planet Earth. So, planet Earth, even though our entire atmosphere is made out of things like nitrogen, oxygen, water, all that stuff, each part of the air, like the part over North America, might have a different pressure system than, let's say, Europe or the Pacific Ocean. Or even Colorado might have a different pressure system compared to, like, New York City, Minnesota, or California. So the air is always changing due to different things, creating low and high pressure systems. So, our learning target today I will describe high and low pressure systems so I can compare and contrast different systems and the weather they bring. And I know I'm successful when I can find which days in my weather data have high and low pressure systems. So, looking at things like humidity, pressure, and the certain weather we have, you'll be able to mark out which days on your weather data you predict or infer have a high or low pressure system. So let's go ahead and get starting just talking about pressure here. So you should have your notes glued in at this point, and at the top we're doing a little bit of some density review. At the beginning of the year, we did our experiment where we were testing if something would sink or float in water, and that has to do with density. And density is just how close together the particles in an object are. So let's say I have a plastic BB and a metal BB. The metal BB is going to be more dense because those atoms in it, those particles, are closer together. There's less space between them, so it's more compact, more dense. Um, Now, density can be swapped out for pressure here because we're talking about the air. So the air, its pressure is the same thing as its density at any given time. So a higher density means a higher pressure, and that's when our particles are closer together. We can fit more air in that column of air that's over you pushing down. That's why it's higher pressure. We're able to pack in more particles to push down. And then low density and low pressure is when the particles are farther apart. So they've spread out. This actually means we can let things like water and things like that in. You'll take some more notes on that when you get to Miss Carter's video on low pressure. But please make sure you have this in because we want you to see the connection between density and pressure. They're the same thing. We're just trying to talk about the space between the particles we have. As soon as you've got that written in, please continue on to the next piece. So, pressure changes, right? Like if we have high pressure, I know in my class we've talked about dogpiling on someone. The more people you put on top of them, the more compact the humans are, the more weight you have on the bottom person, and the less fun it is. If you ever go down scuba diving, you're increasing the pressure because you have the air and the water pushing down on you. So you feel that pressure in your air. When you go up, the opposite happens. You actually lose pressure. So the air wants to expand out, it wants to become less dense, go free, and expand. That's why you get that super puffed up bag of chips when you go up into the mountains. Same thing also happens with your ear. Your brain and the air in your ear wants to expand. You just need to pop your ears to let that air expand out to stop um, to let it actually expand out and relieve the pressure on your brain. Now, this is happening with the air, and this is going to affect the weather we see. But obviously, air is different from humans, so there's going to be some different changes. Oh, sorry. Um, so make sure you're down to this table right here. What you should do, and please make sure you are listening carefully. Please label this number one as high pressure. Number two is low pressure. Again, number one should be high pressure. Number two should be low pressure. Press pause and continue once you've done that. Now, when we talk about air pressure, we're going to be looking at four characteristics, four observations. First of all, we're going to be looking at its density. Next, we're going to be looking at whether it is a pushing force, like is it pushing down, or is it a pulling force? It's pulling up. That has a lot to do with the air around it. This actually has to do with convection cycles, which was just what we talked about with the water cycle. Instead of water now, we're talking about air. And then major weather events. And this is going to be important for tracking our weather. If we can see the weather event, we can start making a more accurate inference about what kind of weather events. We will also be doing an analogy or connection as well as a definition. So please be ready to go and move on to the next slide so we can cover high pressure with Mr. Severson. So let's start with that what is piece right up here. High pressure system, our first type. It is an area where the air particles are pressed closely together. So in other words, this air has a high density and the air is pushing down. So as we're filling out this sheet, we've got the what is, the density, and the pushing and pulling force. So again, it's an area where the particles are pressed close together. So this is very dense air. And because it's dense, just like that metal BB in the water, it wants to push down. It wants to push through the air down to the ground and pushing down on you. And you can see that here in this example. The air above our friend here is getting so heavy, it's just pushing down. It's going all the way down to the ground, pushing on everything as it falls. So please make sure you get that stuff written in. Some weather that we would see with that because of that pushing force, we actually associate a high pressure system, even though it sounds miserable, it's actually associated with nice weather. As you can see in this diagram, high pressure equals happy weather. And what we mean by that is like our clear, sunny, and calm weather. I pointed out these key words because you might want to write these down because these are the things you would see on like a weather report that you're supposed to be collecting every day. So whenever we see that, that is a sign that says, I can predict that there's a high pressure system. Let's double check with the data to make sure that is the case. So that's our major weather events. Nice, happy, sunny, and clear weather. We can still have a couple of clouds, but for the most part, we're going to be looking at clear. So like cloud coverage, I would say 10% or less. Now, a word to the wise. High pressure always has sunny and clear weather, or mostly has that, but not all sunny and clear weather means that there's a high pressure system. One thing, often before major storms in different parts of the world, this was very common in Minnesota. You could have a very clear and sunny day, but it was very humid, but then a storm would come through. And if you recall, storms are not part of that high pressure system, so something else was going on here. So please be very careful that that is a good starting point, but we check our data just to make sure that that is not the case. Let's talk about some analogies and connections. So our air is always moving. You could think about our high pressure system as like blowing down through a straw or like a, oh my gosh, I'm sorry, I can't think of this, kids. But I'm thinking of an air pressurizer. When you spray it out, everything goes flying in all directions because it's spraying down. High pressure is just like that. It's pushing all the air out around it, just like in this diagram. So as it pushes out, all the other air gets pushed around away from the source of where it's dropping, which makes sense because when you spray something down with high pressure hose or air, everything flies out in all other directions. Another way you could think about this, and we'll show you this in class here later this week, if you think about a sponge is a good analogy for the air itself. The sponge can hold water, it can squeeze out water, just depending on the pressure that's on it, just like the air. So if the sponge is being squeezed and I dip it in the water, it's not going to take in any air. It's going to be a lot more drier than if I were to leave it open. That's just because there's no space. Remember, this is a very dense system, and it's squeezing all the water out, and it's not letting any water in because it's so dense and the particles are close together. So those are some connections you can make. If there's any other connections, feel free to write them down and share with your teacher. We would love to broaden our knowledge of analogies. And that covers high pressure systems. Please make sure that you are reviewing these notes. This is set up as a table and graphic organizer for you guys to go back and use. Now, please enjoy the low pressure system with Miss Carter.